In this module, we'll be discussing the VMware vDefend Security IDS IPS feature. We'll be discussing the distributed and gateway IDPS and use cases. To start off with the distributed IDPS, we have to take into consideration that it's not a traditional IDS IPS. That approach would drive up cost and complexity within the data center. Also, adoption was limited to your critical and regulatory mandated segments within the infrastructure. Last, you would have to hairpin traffic back and forth to centralized appliances. This resulted in higher throughput constraints, selective traffic inspection, and lack of vMotion support, resulting in stale policies. Now, if you look at the new architectural approach, it allows you to analyze traffic at every workload. This provides scale-out architecture with an increase in throughput, absolute coverage with no blind spots, and dynamic policies move with your workloads. This creates operational simplicity to support your workload mobility. The policy and state move seamlessly with the workloads, regardless of existing or new workloads, which inherited the policies independent of their location. Now, again, it's not another IDS implementation. This distributed IDPS is unique in that it can be applied to any virtual NIC of every virtualized workload in a transparent fashion. No one else can do this. And take note, it's not a host-based IDS, which suffers from the same issues that all agent-based approaches do. The NSX IDS IPS provides elastic throughput, simplified network architecture, operational simplicity, and it utilizes stranded compute capacity. If we look at pattern matching for signs of known attacks, that's the basic fundamental concept of an IDS IPS. IDS IPS inspects traffic that are specifically allowed in or out of a firewall policy. Traditionally, adding that was expensive. Okay. The NSX vDefend IDPS, it's as easy as adopting the DFW. If the policy's there, you follow suit with the configuration of the IDPS signatures. You don't have to worry about network changes, no hairpinning of traffic, no loss of control or visibility due to the network topology. It works on existing DVPGs and overlay segments. And with the IDPS distributed, it's a control point that is situated logically at every VNIC of all VMs, allowing for least privilege access. Within the VDPI, it initializes the DF filter channels. You'll ensure shared memory is created for VDPI IDPS to read the packets punted by the kernel module. So these packets are then released back to the kernel module once all the processing from the VDPI IDPS have completed processing. The two modes within our IDPS, detect and prevent. Obviously, detect is out of band. Regardless of the signature action, we're just alerting on it. No prevention is actually taken. But with detect and prevent in place, you're actually taking a per signature action defined in the profile selected to take whether it's drop, reject, or allow an alert into play. You'll notice that that's configured within the actual policy. For best practice, most customers will commonly start with detect only. Then, after tuning for false positives, they'll change it to detect and prevent. But keep in mind, for an attack to be blocked, an end gate must be performed. The actual mode must be in detect and prevent, and the signature itself must have an action of drop or reject. So the action defines what the actual signature, when triggered, is performed. All signatures are shipped with a default VMware recommended action. most obviously, as you can see on this screen, is either alert or reject. The alert is typically used in new deployments, as I had stated. Your drop and reject are commonly used for high fidelity situations and signatures to ensure no false positives, high exploits, okay? And after having initially been deployed in alert only mode. Reject does eliminate the long timeouts due to the silent drop. And please keep in mind on this screen, this is based on an October 2022 signature set. This has increased over time. In regards to viewing the signature set, you just go to the top, click on the Security tab, go on the left side pane of the window, click on IDS IPS, and then you'll notice View and Manage Global Signature Sets. Once inside here, do we have coverage for a particular vulnerability? Well, you can use the filter and base it on criteria. You can also use an end gate in that criteria. Globally modifying these signature sets, keep in mind, disabling signatures, if they're irrelevant to your particular customer or situation, it says they're not available in any profiles. And if they were active in a current existing profile, they're now removed. You can also override, obviously, the default action. So if it's set to alert, you can block this. Ensure false positives don't lead to blocked legit flows, though. Each signature contains metadata. Those profile group signatures, they're based on that particular metadata. You'll see on the left-hand side, we have the application and the database servers and the associated signatures within those sets. They could be within severity, attack types, attack targets, the CVSS score, or particular products affected. Now, NSX ships with a default profile. It's based around critical severity signatures only, or between criteria of the same type and between criteria of different types. When we look at the granular application of curated signatures, you'll understand that the profiles are dynamic. Signatures are added and removed with signature updates. Okay. These profiles are applied to applications and traffic via the rules that we've already done within the distributed firewall, which is then merged into the IDPS configuration. So again, when you look at this, you need to understand you're following suit of whatever your firewall is configured for. Your profile should align with that allow or deny. NSX 4.2 does support up to 100 profiles. Globally disabling those signatures are not available for inclusion within the profiles. Just keep that in mind. And once you exclude them, they're gone. For CPU over subscription features, what we're looking at is we can sit here and say, apply it globally or at a role level. It's going to look at it per packet if you'd like. The performance, though, it's configured to drop traffic or bypass inspection. You'll notice here on the screen that by default, it is set to bypass, okay? Basically, the IDPS engine will reach 100%. After that, traffic is bypassed. Once it comes back down, it goes back to utilizing the engine again. Now, logs can be sent to syslog, ARIA operations for logs, Splunk, whatever you'd like. Alarms will be generated at 80%, 90, 100% utilization. All you have to do is click the syslog button over to the right to enable that feature. But again, let me stress, the default is bypass. If you'd like to look at the signature details, feel free to go into the signatures as we had stated before, looking and filtering on a specific signature set. Often it's critical to understand what you're actually looking for. Is this applicable within my environment or my flow? Well, you can see this is visible from the GUI. For the scores, this is how our IDPS will create an impact score and then determine a severity. Your confidence score. This is the confidence of a detection actually being accurate. It is applied at 0 through 100 scale. The higher score would indicate obviously higher confidence, meaning less lower false positives. A lower score would probably mean that, this is going to accrue quite a few false positives, and you're going to need to take that into factor. When we look at the risk score, this is a numeric value indicating quote unquote badness of the threat. How much can it impair? The risk score again is based off of 0 through 100, and this also factors in to the impact score. So when you finally have the impact score combined of the risk score and confidence, you're basically evaluating saying this is the overall exception and severity that this accrues to. 5 levels indicating badness of a threat is critical, high, medium, low, and suspicious. Based on the signature severity value carried in the signature, CVSS, or classification type. Within the use cases of the IDS IPS, we're looking at it from a regulatory compliance, virtual zones, discrete appliance consolidation, or virtual patching. When we take into concept the regulatory compliance, we're looking at it as a software-based IDS IPS for your critical applications. You can achieve this compliance for things like PCI DSS, HIPAA, SOX, eliminating those blind spots. Creating zones in software without cost or complexity, or even within air-gapped networks, or creating physical separation. And then we can secure the vendor, partner, provider, tenant traffic. Anything that goes between them could be susceptible. Within the discrete appliance consolidation, you're looking for replacing discrete centralized appliances, allowing you to leverage the native IDPS implementation. Simply turn it on. Last, virtual patching. This prevents lateral movement of attackers by blocking these known vulnerabilities. Combine this with signature-based detection, anomaly detection, and protocol conformance checks. Moving on to the gateway IDPS, as you can see on the left, we have the green zone and the orange zone. The VM from the orange zone to a VM in the green zone can have an NSX IDS IPS policy applied. The gateway can perform this for all members of the network. Please keep in mind, when you look here, you can actually see that what we're doing in the orange zone is applying it specifically at the T1 gateway, the uplink and service interface. However, on the right, we're actually stating that we're going to do this down to the east-west traffic for the green. So keep that in mind. It's implemented on an NSX edge down to the T1 gateway. It can detect and prevent intrusions at network or zone perimeter, support for all the workloads, same signature sets across the entire distributed IDS, IPS, and gateway. And then you can combine it with decryption policies. This is same or different profiles on the DFW and gateway firewall. So keep that in mind. You can rinse and reuse as necessary. For zone, environment, or tenant separation, you really have to look at the traditional DC zone firewall and compare it to a multi-tenant environment within an NSX overlay network. Okay, the first hop centralized firewalling for any workload through the service interface. You can then augment network independent access controls for the DFW with network-based zoning based on the gateway firewall. So your north-south access control and threat protection for any workload, and north-south outbound filtering and threat prevention for VDI. You'll notice in the middle, that we do have those workloads by tenant, zone, and environment, each one having its own IDS IPS capability. When looking at the NSX gateway security, ensuring IDPS functionality is to ensure when you deploy an edge, it's at a large or extra large size appliance. And then when you look at the feature set from the edge form factor, notice that the capabilities for this security feature, you're going to obviously get the best bang for your buck with the extra large edge. However, please keep in mind, the only reason you would need that is for including malware detection or sandboxing for unknown threats. Your basic TLS inspection and IDPS can be consumed within a large form factor. As far as best practices are concerned, why would we use the IDS on the edge if we can already do it from a distributed IDPS? Well, TLS inspection for one. Performance. Packet mongers, bare metal workloads, and multi-tenancy. These are perfect use cases to use a gateway appliance versus your distributed firewall. In regards to the use cases, the first we'll say is, well, when and where do we deploy the IDS IPS? Do we align it with the environment? Do you define it within the development or the production or both within shared services? Do you then create the profile based on critical and high severity workloads? You then turn around and tune these workloads and flows to ensure that you're getting rid of any of those false positives. Do you want to focus on the VDI endpoints? You can actually say specific attack targets, the client endpoints, client and server connections, or aligned with your application tiers. Remember, we have a web, a presentation tier, app, the middleware tier, and the database backend tier. Notice how we can also discuss the environments as a DMZ versus internal aspect, but each one can have their own policy based on the color coding. So notice web servers within the DMZ have their own policy, and the policy is centered around attack targets equaling web servers. The application servers group, that is based on products affected, like Drupal, WordPress, and then your database servers, looking at things like MS SQL, MySQL, CouchDB. Each one of these are separate profiles applied to specific workloads dynamically within the distributed IDPS. When you select specific workloads, you can say these are, for example, mission critical workloads, and you can provide all signatures. If they're your quote unquote crown jewels, you may want to ensure not only with the firewall policy rule being adhered to, but you're ensuring that every single packet is being aligned. Keep in mind the host, CPU, and memory. Again, virtual patching. Maybe there's a particular VM who is out of date. That would make it vulnerable and would need assessed. So what you do is you create a policy that is based around vulnerabilities and out of date patches that are required. Ensure things like your CVE scores are included in it with a minimum assessment so that you can ensure everything is included. Let's take, for example, a domain controller attack vector. The problem before is when you're looking at this, you can block outbound, but the firewall policy is pretty much ineffective. If we think about it, domain controllers need X amount of ports. Like if you're still using 2013, you're pretty much opening TCP and UDP ports 53 through 65,535. How useful really is that? Now, again, that's a little excessive, but you're still opening a lot of ports for your domain controllers. After though, now what you're saying is, look, I'm going to allow those on the firewall, but from an IDPS perspective, we're going to look at any source to these Active Directory servers, and I'm going to change it to detect and prevent. Those domain controllers are now guarded by an IDPS property or policy, which now basically says every packet, no matter where it's being sourced from, on the ingress, it will detect any IDPS signature profiles arranged around the signatures for the profile type AD services. And notice these are various signatures within that alignment. Another example would be RDP or SSH attack from, let's say, VDI. You'll again notice that this is just all uncontrolled RDP and SSH access laterally. Okay, this can go east to west and move within the data center. So there's nothing outside because, as you notice on the left, the core switch has no firewall rules. It is beyond the perimeter edge. So when we put the IDPS in place, what we're saying is, okay, let's take, for example, you'll have secure admin jump boxes. What we're going to do is put a firewall in front of every single VDI, web server, database server, everything. We're going to say you can go from a jump server to anything on RDP and SSH. Anything else via RDP and SSH, disallow. So now we're focusing the specific connectivity on these secure admin jump boxes to reduce the spread and control the utilization. Now, every time an RDP or SSH connection is coming outbound from the jump box pool, it will use the signature profile that we built around the jump boxes. And again, here are numerous signature sets aligned to that profile. In the end, if you'd like to see more about how the IDPS works, please log on to our lab. The HOL is 2570-02, Module 01 IDPS. It is free. Please make an account and feel free to extend it should you need more time. That is all for this module. Have a wonderful day.